Hey guys, Mr. Wilson here with our final advanced word problem lesson. Today we're going to try to, at the end of this video, you should be able to rewrite a variable in terms of another variable, and you should be able to set up and solve distance, rate, time problems, or DRT problems. Okay. Alright, so DRT, distance, rate, time. It's important to understand how we find distance. Remember that we can find distance by multiplying. To find an object's distance, you can multiply its speed or rate. We will use rate and time. And I want you to think of time as duration. Okay. A simple example of this is if you travel 40 miles per hour, a rate, for 3 hours, a time, how far would you have traveled? Well, 40 miles per hour for 3 hours means I'm going to do 40 times 3, which is 120 miles. Okay, in this lesson we'll look at two types of travel. Same direction travel, where distances are equal. Or opposite direction travel, where distances are added together. Okay, let's look at a same direction travel problem. A train leaves the station at 1 p.m. traveling at an average speed of 60 miles per hour. A high-speed train leaves the same station 2 hours later, traveling 20 miles per hour faster than the first train. The second train follows the same route as the first train on a parallel track. In how many hours will the second train catch up to the first? Okay. So, looking at what we want to find out, we want to know time. Time is our variable. Okay, everything else we can kind of figure out. We want to find time. So what we're going to do is we're going to fill in all the stuff that we know. So it tells us that train 1 leaves at an average speed of 60 miles per hour. I'm just going to write 60 there. And it says a high-speed train leaves the same station traveling at 20 miles per hour faster than the first train. Do we know the speed of the second train? Yeah, even though they didn't explicitly tell us the speed, they did tell us the first speed, or the speed of the first train, and that this is going 20 miles per hour faster. So I know that train 2 is going 60 plus 20, or 80 miles. Alright, now time. When we think of time, remember that we are not talking about like a time on a watch. We are talking about duration. How long is this lasting? Okay, and so we're thinking about how long are the trains traveling on the stations or on the tracks. The first train, we don't know how long it's going, or we would have the answer to this question. So we're going to write T. The second train, we don't know how long it's going, but remember or realize that they're saying it left 2 hours later. So as far as duration goes, if it started 2 hours later and it's going to catch up, that means it's going to spend overall 2 hours less time on the track. So we can rewrite this as the time that it takes for the first train minus 2. Okay, so notice how time is figured. It is time spent on the track. Okay, it is not 1 o'clock. It is not important to know that the second one leaves at 3 p.m. It doesn't matter. Okay, since we know that the trains covered equal distances because it says when will they catch up. Catch up means they're going to have equal distances, right? We can set up the equation using an expression that represents each train's distance, because distance, as our equation set it up, distance equals rate times time. So both of these are distances. So the distance for the first train is 60 t. The distance for the second train is 80 it's really important here, guys, that you put these in parentheses. T minus 2. Because now this is our equation. And now we can solve it. 60t equals 80t minus 160. We will then subtract 80t from both sides. Get negative 20t equals negative 160. And then divide by negative 20, so we get that t is 8. Okay, so t is 8. It took 8 hours. The train was on the track for 8 hours. Okay, so it says, what time of day was that? Okay, now it's important to know the time. Okay, the first train left at 1 p.m. 8 hours later, they caught up to each other, and so it would be 9 p.m. All right, so there we go. There we have it. There's our equation. Next, we have opposite direction travel. So in this case, let's read our problem. It says, 2 jets leave Dallas at the same time. So they leave at the same time. One is flying west at 50 miles per hour faster than the other. After 2 hours, the jets are 2,500 miles apart. Find the speed of each jet. So the thing that we don't know here is speed or rate. Okay, and so let's look at these. 2 jets leave at the same time. Well, they fly in opposite directions. I'm going to just draw arrows because that's easier. Okay, one's flying west 50 miles per hour faster than the other. So I don't know how fast either of them are going, but one's flying west 50 miles per hour faster than the other. So I'm going to say this is R plus 50. Okay, that's how fast it's going. Now in doing this, I need to make sure I understand what R means. R then is the speed of the other jet, or the rate of the other jet. Because what they did is they made a common link between these two unknown speeds. I don't know how fast this is going, but it's going 50 miles per hour faster than this one. Okay, and so now I've had that common link, and that's why I can use R for both of those. Okay, now for time in this equation, it's pretty simple. They said 2 hours. So our time for this equation is 2 hours. And so after 2 hours, because these things are 2,500 miles apart. So this plane's here, and this plane is here. Okay, 2,500 miles apart. And so what I can do then is I can add their distances together. This distance that they travel from the airport plus this distance that he traveled from the airport equals 2,500. Okay, and remember we have our distances. Distance is rate times time. So in this case we have rate times time, which again is going to be important that anytime we have addition or subtraction here, that we will group those. So the distance of the one going west plus the distance of the one going east, which is just 2r, will equal 2,500. So 2r plus 100 plus 2r equals 2,500. That'll give us 4r plus 100 equals 2,500. Subtract 100 from both sides. 4r equals 2,400, and that will be r is 600 miles per hour. So now I can find the distance, the rates that both of them are going. The one going east is 600 miles per hour. The one going west will be 650 miles per hour. Okay, you could use a different table. So you could have said the one going west is R, and the one going east is going slower than the one going west. You could have said R minus 50. Okay, that would change how your equation looks, and it would also change what you said R was, but it would not change the speed of the two planes. So notice if you set it up this way, if you thought this way, you said, hey, this is R minus 50, not R plus 50, you could do that with the different planes, but however you solved it, you would have found that for R minus 100, 2600, sorry, 2500, so 4R would equals 2600, divided by 4, you would have got R to be 650. Okay, which would have showed you that this plane goes 650 miles per hour, and this plane still goes 600 miles per hour. So even if you set it up differently, or you use the variables differently, you would have got the same answer. Okay, since we know that jets covered different distances, we can set up an equation to solve the problem. So equation from the first table, I've already done that, sorry. 2R plus 50 plus 2R equals 2,500. From the second we have 2R plus 2R minus 50 equals 2,500. Okay, again, the speed of the jets are the same, no matter how you set it up. Okay, so there we have it. We will need some practice with these just to set them up and think about them, but as you go through it, make sure you are defining your variable, setting up your table, getting your distance, rate, time together so that you have the foundation to solve this rationally. All right, see ya.